Today, all municipalities are required to spend large amounts of money to repair their deteriorating infrastructure. Sewers are a major part of this infrastructure. Repairing these sewers requires funds from already overcommitted budgets, as well as a lot of time rerouting traffic and maintenance of interrupted services for years to come. Relining came to the market first as a sewer repair technology requiring no excavation. Soft plastic liners were pulled in from a prepared access ditch. Later on, epoxy-based cured-in-place fibrous liners were used. Both liners have one feature in common. They have to be applied from end to end, or manhole to manhole. Link Pipe President Lembit Mimets began his career as a municipal engineer. He noticed that only a small percentage of the sewer pipes were actually damaged. Subsequent statistical investigation revealed that on average, less than 6% of small diameter sewer pipes actually need repair. Since spot repair is applied to the small damaged area only, it can drastically reduce repair costs. For the same project, the cost of spot repair can be less than 15% of the comparative cost of relining. Link pipe technology is focused on spot repair. The grouting sleeve is applied only to the damaged part of the sewer. The grouting sleeve is a simple device. A stainless steel core is covered with an absorbent gasket. Before installation, this gasket is filled with a polyurethane grout. The grout cures when it comes in contact with water. Limit straps surround the sleeve to prevent it from overexpanding and causing more damage. The grouting sleeve comes in 3 styles. The double-flared style is used in both single-sleeve installations and multi-sleeve installations. Multi-sleeve installations can also involve sleeves with a single flare or no flare. Two types of grout are presently used. Before it is used, G100 grout must be mixed with cool water in the ratio of 7 parts of grout to 1 part of water. The creamy mixture is then worked into the sleeve gasket. In approximately 18 minutes, the grout will start to react. The reaction is indicated by foaming. G200 grout is applied in pure form to the sleeve. This grout permits the sleeves to be prepared in a workshop before going to the field. After the grout is applied, the sleeves are wrapped in polyethylene sheets for storing. This prevents air and moisture access and guards against early curing. Sleeves prepared ahead of time can be stored in a cool, dry place, such as a paint storage room, but they should not be stored overnight unless the installer can make sure that the grout will not be affected. Before installation, the sleeve with G200 grout is doused with water. After this, it takes approximately 20 minutes before the curing starts. The equipment needed to carry out a grouting sleeve repair is very simple. Flashers, an inline TV camera, and cables on pulleys are standard equipment in sewer work. To install the grouting sleeve, one also needs a 1 to 2 horsepower air compressor, a suitable length of 1/4-inch air hose, preferably with quick couplers, a control gauge to maintain the air pressure at the desired level, a paint roller, a flow-through sewer plug with wheels and a spotlight, the grouting sleeve, and grout. The dry sleeve gasket is filled with grout, starting first with the lower layer of the overlapped gasket. Rubber bands are then pulled over the gasket to hold it down as it travels through the sewer. This will prevent ripping and other damage to the gasket. Now the rest of the gasket is filled with the grout. We will see how the grouting sleeve is used to fix a 12-inch diameter sewer pipe. A transport cable has been set up between the entry manhole and the far manhole. A set of wheels is removed from the plug. The sleeve is pulled over the plug and the wheels are reattached. Now, either the polyethylene film is removed from a sleeve prepared ahead of time, or grout is applied to a dry sleeve. With the overlapped gasket in the 3 or 9 o'clock position, the plug is inflated slightly to keep the sleeve from slipping on the plug while it travels through the sewer. The distance from the center of the light to the near end of the sleeve is measured and recorded, to be used later to position the sleeve accurately. If G200 grout is used, water is poured over the sleeve before it is pulled into the pipe. With the CCTV camera usually traveling first and looking back on the sleeve, the assembly is pulled by cable from the far manhole to the installation site. In this case, the installer chose to have the camera follow the sleeve. As the sleeve is pulled along the sewer, the light spot on the sewer wall is observed on the TV screen. When the light reaches the far end of the area to be repaired, it is stopped. The cable is then slowly pulled forward the required distance until the end of the sleeve extends at least 4 inches into the sound pipe. The air is applied by setting the control gauge to the desired pressure. Wait until the pressure in the plug reaches the gauge pressure, then release the air. The camera is now pulled back through the sleeve for a final inspection. The job is complete. Normally, the whole installation process from start to finish takes 10 to 30 minutes. Actual results will vary depending on the installer. The stainless steel core of the sleeve adds structural strength to the existing pipe. The grout penetrates the cracks and joints as it foams during the curing process and glues all the pieces together as it forms a resilient composite material. The new composite structure is stronger than the original pipe, but it also retains flexibility and resilience due to the urethane matrix. The resulting pipe withstands soil movements, such as earthquakes, better than the original rigid pipe. Different repairs may require the use of several sleeves. 2 basic methods of multi-sleeve installations are used: the series method and the parallel method. In the series method, 1 sleeve is installed at a time. Usually the furthest sleeve is installed first. Subsequent sleeves are then pulled unflared end first into the previous sleeves by the amount of overlap. Continuity is created by overlapping the end of every subsequent sleeve by approximately 2 inches or 50 millimeters with the preceding sleeve. The expanding grout seals the slightly reduced diameter of the overlap, ensuring an accurate fit. Parallel installation is done in 2 stages. A practical limit is 3 sleeves in a train. If 2-foot or 600 millimeter long sleeves are chosen, this covers a total repair length of 9 feet or 3 meters. In this example, a train of 3 plugs and sleeves is prepared. The plugs are equally spaced so the sleeves are 20 inches or 500 millimeters apart. All the plugs are pulled by the same cable and connected to the same air hose. The train is pulled to the repair site and all the sleeves are expanded at the same time. This completes the first stage. The second stage of the installation consists of 2 sleeves without flares. The train of 2 sleeves and plugs is pulled and located over the gaps left by the first installation and expanded. This repair is particularly time efficient if the G200 grout is used and sleeves are prepared before going to the field. Special care should be taken when air pressure is regulated in this type of installation. Consult link pipe for further details. As a rule, offsets that are big enough to allow backfill or water to enter the pipe are easily realigned since the soil around the sewer is already loosened. For security, first the plug alone is inserted and inflated under the offset. Movement of the pipe indicates that the danger of damage to the sleeve is unlikely. Then, the sleeve is inserted under the offset and expanded. The expanding grout seals the joint against water infiltration or future loss of backfill. The sleeve stabilizes the offset against any future movement. Often roots penetrate through the damaged pipe or offset. This makes realignment more difficult. In this case, the use of a restorer from link pipe with a high-pressure plug is recommended to create an unobstructed opening for sleeve expansion. The restorer assembly is pulled under the offset and pressure sufficient to break up the pipe is applied. The pipe breaks and creates the clear opening for the sleeve. After cleaning out the debris, the grouting sleeve is installed over the opening. Usually this process realigns the pipe as well, or creates a smooth transfer across the gap. Groundwater infiltration is one of the main causes of sewer collapse. Flowing water removes the soil surrounding the pipe. The remaining soil falls onto the pipe, causing it to collapse. In all cases, grouting sleeves installed over the water leak can be made to stop the flow. If enough grout is applied, air testing or elimination of the infiltration confirms a complete seal. This process also prevents further deterioration of the sewer pipe. On occasion, double sleeves have been required to seal high-pressure water leaks. Free-flowing chemicals and foams are very effective at killing roots in the short term, but they also contaminate the soil. In addition to raising complaints from citizens concerned over the environment, governments may restrict or prohibit the use of such chemicals. The chemicals also disperse with time, and roots regrow. Link pipe's solution to the problem of roots is borrowed from the tradition of Scandinavian plumbers. Copper hoops are placed over a grouting sleeve. When the copper comes in contact with sulfur in the ground, copper sulfite is formed. This substance is lethal to roots and acts as a local barrier that roots will not penetrate. It also lasts forever. Since the copper is surrounded by grout, the production of copper sulfide is confined to within a fraction of an inch from every copper strand. The total amount of copper sulfite produced is so small that it has no significant effect on the ambient concentration always present in the soil. The cost of this process is very minimal. Any length of missing pipe can be restored with the grouting sleeve. The series method of installation is recommended, reversing the installation order. The nearest sleeve is installed first, and the rest are telescoped out until the gap is bridged. For a more stable installation, fly ash is used to form a firm backfill surrounding the repair. This prevents further collapse of the soil and allows water to escape easily from the backfill. The grouting sleeve with a lateral opening can be placed directly over the lateral entry without blocking the flow. The sleeve is provided with a locator device designed by Link Pipe Inc. To place a sleeve over the lateral, a cable is first flushed from a toilet, cleanout, or breather to the downstream manhole. The cable is then connected to the locator. From here, the sleeve is pulled to the lateral opening. The locator cable is then pulled from the house, drawing the locator pins into the lateral. These pins keep the openings of the sleeve and lateral lined up until the sleeve is fixed in position. The installation from here on follows the standard installation process described earlier. The just-in-time JIT system of repair was developed by Link Pipe to reduce the cost of spot repair even further. JIT is also suitable for emergency repairs. It eliminates the need to excavate and turns emergency repairs into service calls. Normally, restoration projects require 2 contracts, first for inspection and later for repair. Often the inspection and repair are separated by an average of 3 years. Meanwhile, the pipe deteriorates further and engineers must prepare contract documents. When work is finally started, contract extras have to be negotiated, adding to the cost and making budget control more difficult. The JIT has an approach similar to the one already used for emergency repairs, combining the inspection and the repair into one operation and one contract. This allows the repair to be finished in a much shorter period of time and brings tight control over budgets. During inspection, a sewer is usually flushed and cleaned anyway. Often this requires pulling in cables and cutting roots as well. When damage is discovered, it only takes another 20 minutes to install a sleeve, and the repair is done. It is estimated that the JIT single contract system can save more than 50% over the present double tender system. Spot repair contracts are often combined into general repair contracts, which also include replacement by excavation and relining. However, spot repair contractors are usually small inspection companies and do not have equipment for relining or excavation. In order to bid on these contracts, they are forced to combine with general contractors. Consequently, the general contract contains at least 2 levels of overhead and profit. Costs can be reduced by separating out spot repair contracts. By combining the inspection and repair into one operation and repairing only the damaged areas, municipalities can save significant amounts of money, avoid traffic nightmares, and continue to provide their citizens with the level of service they demand within set budget constraints.